All right, applied calculators. In this screencast, we take a look at marginal functions. Now, nothing we do here from a mechanical standpoint is new. We're going to take derivatives for particular reasons that will be clear as we go. The idea of marginal functions is huge in the School of Business. So let's start with a basic definition. Let's deal with cost first. There are similar definitions for revenue, for profit. There are similar definitions. The definition of marginal cost is the cost of producing one more unit. That's marginal cost. Now, there are two ways to find the cost of producing one more unit. You can, excuse me, you can find the cost at x plus 1 and the cost at x and subtract them. This is tedious. Or you can find the derivative of the cost function at x, and this is usually the way we approximate. Both numbers are close. They give you a this is exact, this is an estimate, but the estimate is usually good enough that most business calculus books say just find the derivative of the cost function at x. So let's try this. Let's suppose that the cost of producing X units of perfume is, that's going to be C of X is 3X plus 2 over X plus 4, where C is measured in hundreds of dollars. Hundreds of dollars. That is to say, if you want to know the cost of producing 10 units of perfume, you put a 10 there and a 10 there, and that number is the number of $100 of perfume, the number of hundreds of dollars it would take to produce 10 units of perfume. So if we were to find, for example, C prime of X, C prime of X, well, that's the bottom times the derivative of the top minus the top times the derivative of the bottom. For the rest, we won't be scared. It's all over the bottom square. This is calc, this is calc, this is calc. And that turns out to be, with some pretty impressive algebra, 10 over x plus 4 squared. Now, this is the marginal cost function. What does that mean? Well, we can find C prime of 10. I did this by using my machine. We could find C prime of 20. I did this by using my machine. What do these numbers mean? Well, this is a number of hundreds of dollars. So that means it would cost $5.10. It would cost about $5.10 to make 11 units if we were already making 10. So what sometimes we say is this is the cost of making the 11th unit. What does this, what does this mean? What does this mean? This means that it costs approximately $1.74 to make the 21st unit. If we were already chugging along pretty good, making 20 units of perfume, to up the production to 21 units would cost an additional $1.74. That's the idea. Now, we could talk about the average cost function. The average cost function is called C bar. And C bar is C of x divided by x. It's the cost for making x units divided by the number of units. So in our case, C bar is the cost function, sticking with the perfume example for a moment, divided by x, and that's 3x plus 2 over x squared plus 4x. Well, what do we learn if we find c bar prime? What does that show us? Well, we can do this. It's the bottom times the derivative of the top minus the top times the derivative of the bottom. For the rest, you won't be scared. It's all over the bottom squared. This is calc, this is calc, this is calc. And what does that mean? Well, a little bit of algebra here. What do we learn from this? Well, we could learn that c bar prime of 10 is a very small negative number, and c bar prime of 20 is an even smaller negative number. And as x grows, c bar prime gets closer and closer to 0. What does that mean? Well, that means the more units of perfume we produce, the less expensive on average it is to make them. And that makes sense because the overhead gets distributed over all of the units of perfume. So this almost makes sense. I want to talk about a couple of other ideas. I want to talk about revenue. Revenue is price times demand. This is a price function. This is a demand function. Sorry, this is the demand. So there's a price that depends on demand, and we multiply it by demand. For example, suppose that the price function is 1,000 over x squared plus 1,000. This is the price of a stereo with demand x. The revenue function is price times demand. That's this times x. So what do we gain if we find r prime? And I won't bore you with how we find r prime. What does this tell us? This is the marginal revenue. It is the revenue we expect to bring in by upping our production from X by 1. So if, for example, R prime of 10, that turns out to be $990. What does that mean? That means that the revenue, if we bump from 10 stereos to 11 stereos, is about $990 more. We can expect to bring in $990 more if we up from 10 stereos to 11 stereos. Okay. One other thing to consider, and that is this idea of elasticity of demand. So the demand, that's a problem. That's a problem. The demand function is some function of P. And if the demand function is some function of P, then the elasticity of that demand is negative P times F prime of P over F of P. Suppose that F of P is 108 minus P squared for the price P in dollars. What is the elasticity of that demand? The elasticity of that demand is negative P times F prime of P over F of P. And this happens to be 2P squared over 108 minus P squared. So it's time to ask, who cares? Well, if elasticity is greater than 1, we say that the demand is elastic. Now, what does that mean? That means that little changes in demand result in big changes in price. Right. Little changes in price oh, golly, let's try this right. When you wear elastic, little changes in price mean big changes in demand. Oh, wow, that's not what we want. Little changes in price mean big changes in demand. And if elasticity is less than 1, if E is less than 1, then the demand is inelastic, which means that little changes in price bring little changes in demand. Well, depending on what the price is, E is either greater than 1 or less than 1. It happens in this case that if the price is greater than 6, then the demand is elastic. And if the price is less than 6, then the demand is inelastic. Small changes in price lead to small changes in demand. How did I come up with that? Well, you set this thing equal to 1, and you solve a quadratic equation, which everyone can do from their high school experience. So sometimes we will be asked to construct this elasticity function, which is going to involve derivatives, and then we're going to be asked to decide for a particular price, is the demand elastic or inelastic? And you'll need to be able to break that down. All right, that's it for us. Glad you stuck with me longer than 10 minutes. We'll see you in class.